so I'm going to attempt to explain axotomy and Wallerian degeneration in 4 simple diagrams. So, Wallerian degeneration is the separation of axons and how they die off and regrow. This is going to take a fair amount of me looking at my notes, but hey, it's okay. So we have our little friend here. So our nerve. It's not a stickman, it's a nerve. There's its nucleus. Right. There's attached there. Whoops. Right, so what happens? It gets severed here. Right? Severed here. Right? So then we're going to draw it with its friends. So, going to have a friend on either side. And, right, that's horizon line. And then, so it's been severed. So here's its bottom part, here's its legs, here's its head. They all have nuclei. So there we go. So its friends go, right, we're going to help you out here, because they can see this part has needs a bit of help. It's going to die. So these grow collateral sprouts, right? And they're trying to help. They're trying to help this part stay alive. So you've got collateral sprouts. Yeah, so and they are trying to help this bit. Yeah. So then we'll go. Well, let's keep it simple. Let's keep it nice and simple. So yeah, the collateral sprouts. However, those collateral sprouts actually, although they tried, they failed. So we have our three amigos again. Another amigo here. Okay, and so, and then this chap in the middle, the severed one in the middle. So those bits, those bits at the end, they the distal bits, sorry, they die. Okay, they die, and so do the collateral bits as well. They failed. You know, they tried their best, but they failed. And then what happens? So, this is the clever bit. There we go. 1, 2. And then you've got your chap in the middle, and his proximal end regrows. It regrows. So the proximal end regrows. Magic. So, I'll talk about it in a tiny bit more detail. Oops. So, I'm gonna. So what we're gonna do? So, we'll run for it again in a little more detail. So the so yes, we said about this bit, it dies off. So the severed part, so you dunk dunk, gets severed, and then the severed part undergoes apoptosis. Yeah, and there's a chromatolytic reaction, which means the cell body swells. The nucleus moves from the centre, right? So it's eccentrically located, and that means it's knackered. Then the Nissl bodies dissolve, which basically means it gets rid of waste tissue. Central synapses are lost. Growth protein synthesis occurs in the PNS, and then microglial and astroglial reactions occur, and that will be in the CNS. And we'll write that down a bit afterwards. So the distal part of the severed axon degenerates, so it's not receiving any information from the proximal end. Yeah? So it's not receiving any information, therefore it's not needed, so it just degenerates. So these collateral sproutings of the adjacent intact axons, they try to keep the distal end alive. They try, but they inevitably fail. So it dies anyway, and actually, because those bits, those collateral bits, are no longer needed, then they die also. So then we're back down here. It's all dead. And then the proximal end is what's left, and then that regrows. That regrows downwards, and then eventually plants itself back in. And this grows between 2 to 5 millimeters per day towards the target tissue, those being the target tissue here. So, just going to write some notes about this chromatolytic reaction, which I believe we need to know about. So let me just find a suitable coloured pen. And again, this is just going to be bullet points because it's quite difficult to remember. So, a chromatolytic reaction. Okay. So cell body swells. Nucleus. The nucleus gets eccentrically located. Eccentrically located, which is basically the death knell. Then Nissl bodies dissolve. central synapses are lost. Central synapses are lost. Growth protein synthesis occurs in the PNS. So growth protein synthesis, the PNS. And in the CNS, microglial and astroglial reactions occur. As your CNS. Right, so personally, what I'm going to do is look up chromatolytic reactions in on Google and get someone to explain it better than that. But that is your Wallerian degeneration. Magic!